Hi everyone, welcome to regression analysis lecture. This is one of the subjects in the statistical science study program, Department of Mathematics, University of Indonesia. So what we will be doing for this session, still on the variable selection. Um, Previously in another video, I've explained about the concept and algorithm of doing the variable selection, particularly for these three methods: backward elimination, forward selection, and stepwise. And in the other video as well, I already explained how to do these methods in R. So for this session, we will look at the, here I write the caveats of doing the, the stepwise procedure. They are like too many individual t-tests, so it might inflate the alpha or type 1 error, as well as actually the beta or the type 2 error. And also it considers only linear function, while probably there exists any other functional relationships, for example, like interaction terms or higher order terms that are not considered in the model. Okay, so that's why it is recommended that the use of the um, stepwise regression is not to kind of like choose the best model. Okay, that's why in the previous videos I write best in a quote, because it's not actually the best model, but just use it to kind of like blindly select variables if you are given a large number of provided ones. And then among those selected, actually we need to do some more model building to get the more suitable model. Okay, so then I will just show it through our simulation here before on some lags in doing the stepwise procedure. Okay, so before we use this model, this data set, right? That this is a hypothetical data that I generated. Okay, and then before we try to do, okay, this is the backward elimination result. Okay, among those 5 variables, 3 variables are selected, that is x1, x2, and x5. And then using the forward selection, starting with the null model, and then we include the variable one by one at a time, we also end up with this result. Okay, so we also get that x1, x5, and x2 are the three significant variables to be included in the model. And then combination of those two approaches, that is in the stepwise, we got this result, exactly the same result with the backward and with the forward selection. So why I say that this result is not kind of like the best one, because actually I told you before, this is a hypothetical data, and this is how I generated the data. Okay, so actually let's just generate it again if you'd like to. So I asked for a sample size of 100, and then for the x1 I generate it from uniform or random number with the range from 1 to 10. And then I also created x1 squared, and then x2 uniform distribution with the range of 4 to 9. X3 again uniform 1 to 18. X4 is a normal distribution with a mean of 10 and standard deviation of 2. And X5 is also from the normal distribution with a mean of 6 and standard deviation of 2. And then this is actually how I did construct the Y value, that is from X1, x2, x4, I put just like, very little coefficient here. and then x5 should be significant. I put kind of like a large number, and then I put the x1 squared. So actually you can't really say that, okay, just comparing the coefficient here, like what I said before, or x2 I put -6, so it should be significant, and then x4 I put my 0.001, so it should not be significant later. x5 I put 5, should be significant. You can't always say something like that. But in this case, I can do that because, I generated the data kind of like on a quite similar scale. You see that, the range is 1 to 10, 4 to 9, 1 to 18. I mean that there's no data like hundreds or thousands or just, in a decimal, nothing like that. And then even this is from the normal distribution, the range is not really different with the other X. Okay, so that's why I just put the what is it? I can say that by setting a kind of like relatively larger coefficients parameter here, I can say that that's how I put in the one that should come as significant variables are x2, x1, x5. And actually here I put x1 squared. Okay, and then here there's no x3 in here, so that's why in here x3 and x4 should be excluded from the model later if your procedure is correct. And also here we have x1 squared, the coefficient is 1, quite big enough. Okay, so should be x1 squared should be included in the model. Okay, but just like what we've presented here, we ignore at all that what is it, that higher order term here, the x1 squared. And then if you want to compare whether the resulting the resulting coefficient is the same or close to the one that I set up here. Okay, so maybe just put it oopsie. Okay, so this is the y, and then let's say, where is it? Okay, so then here we have that intercept. I set the intercept to be 34, 3, it comes out as 24, but then we don't really need to worry about the intercept. Let's just look at the coefficient for the variables. So here I put x1, actually the coefficient of x1 is 4, but here it gives us the wrong estimate. Okay, and then for x2, -6 is quite close, -5 for 0.6, and here I put x5 is 5, yeah, close enough. So what's wrong with x1? This is just how the the estimation procedure trying to do the optimization, because the model only say that x1, not telling it all about the higher order. So the closest one that gives you, kind of like the relatively accurate prediction to the value of y, so it puts it like this. And I think this is as the consequence of not considering the x1 squared in here. This is minus x1 squared. Okay, so that's what we can get from the some lackings in doing the variable selection using stepwise. Okay, but if we look at the plot of, for example, x1 and y here, yeah, it's like this. So actually we can see that yeah, it's just kind of makes sense that if you just put this model, you get okay negative, because we can see it's like this, right? So as x1 increase, then y is decreasing. But at like, some points here, smaller value of x1, actually there's a trend that, as x1 increases, the y is kind of like increasing as well. And then at some point that it just changes the direction. Okay, so that's kind of like an indication of that we need to put in the quadratic or something that represents the curvature. So there's an indication that we should put in the what is it, the quadratic term or a higher order term in the model. Okay, so if based on this, okay, for this we see that, okay, I think x1 should be in a quadratic form, and then if I put that x2, so for example, like if I plot x2 with y, kind of like something like this, probably negative, okay, but not really. The points are really scattered, but yeah, I think that I just propose a linear function of x2. If we try to do x3 here, okay, x3, then we have no pattern at all, so I can expect that x3 to be excluded from the model. And then if we put x4, again, kind of like really random pattern. So x4 should be excluded from the model. x5 looks good, it's kind of like positive trend. So that visualization kind of like gives you the feeling of what you should be done, or you should be doing in what is it, defining or building your proper model. Okay, so again, when we look at before, x1 should be, yeah, there's a little bit curvature here. So instead of this one, although stepwise suggested that this model is the best, but then further examination, I would just say that, okay, I would just do that, what is it? Okay, so I will fit that my model is that, okay, my model is that y based on x1, x2, x5, and then x1 squared. Okay, and x1 squared. Let's see, and then let's see summary of my model. Okay, compare it with the one that um yeah, with this one. This is the one I generated the y. So here we can see now the estimates are kind of like close to the designed or the designed ones when we generated the model. Okay, x1 is 4, this is 5.5, x2 is -6. Okay, x4 here, oh why did, oh okay, this is the designed one when generating the model, and then this is not significant or included in the stepwise procedure. x5 here 5, and then x1 squared, this is -1.12, resembles the one that was set up in here. Okay, and it turns out that adding the square function of x1, it contributes significantly to the model. That is, the p-value here is quite small. Okay, moreover, let's see here. Moreover, if you look at here, the result from the stepwise, you get the r squared is 90.59 and adjusted r squared is 90.3%. While when we add the quadratic term here, it just becomes around 98%. So it really shows that x1 squared should be included in the model, and that one cannot be detected by the just the stepwise procedure. So the recommendation from here is again looking at this. Okay, this is the lacking of the stepwise, and then to get a proper model you should like do kind of like some model building, and here what do we mean by the model building is that kind of find a proper relationship between variables in your model, and the easiest way to do that is by doing the data visualization. Okay, that's all for this session. So um, yeah, thank you for your attention.